Yo, this video goes out to Year 12 and particularly to Mr. Jean-Baptiste. This is the last one for chapter 24, guys, 24D.2, which is about the importance of quantiles. And what this one is about, which is different, is sometimes in a question you are not given the mean, mu, or the standard deviation, sigma. So what we need to do is sometimes we've got to convert the z-scores, two z-scores, so then we can find the mean and the standard deviation. So what we're going to do is we need to use this formula from a few lessons ago. Remember, the z-score is equal to whatever the score is minus the mean divided by the standard deviation. Okay, so we need to use that one. That's going to come in handy. So let's look at example 1. An adult scallop population is known to be normally distributed with a standard deviation of 5.9 grams. If 15% of scallops weigh less than 58.2 grams, find the mean weight of the population. So let's do a little sketch and have a think about what it actually means though. Let me just move this down. Okay, so let's do a rough little sketch, visualize the data and what we're talking about. So we're being asked to find the mean weight. Standard deviation is 5.9 and 15% of scallops weigh less than 58.2. So let's say here's our mean, mu, we don't know what that is. 15% is about here somewhere. Okay, so let's say this bit in here is 15%. And we're saying, because that amount there of scallops weigh less than 58.2. So that means this score here is 58.2 grams. Okay, but we don't know then, we can't figure out what the mean is unless we convert it in to z-scores. So let's write out our info. We've got x is normally distributed with a mean of mu, which is unknown, standard deviation of 5.9. Now we need to use that inverse normal function on the graphics calculator again from last lesson. So if you don't remember, please go back to 24D.1 and watch that YouTube video. But what we can do here is we got to set it up, and we kind of have to, we do need to do a little bit of algebra and equation work. So because we can't use the inverse normal function straight away until after we've converted it to z-scores. So we need to convert this somehow so that it becomes like a z distribution, and then the mean or the mu is 0 and the standard deviation is 1. Okay, so we're trying to convert that into this and sort of then work backwards to get back to up here to find the mu. Does that kind of make sense? All right, so we want the probability of x that is less than or equal to 58.2 grams. Okay. Yep. Now it actually tells me that's 15%, so that's 0.15. Okay. Now normally I'd be able to just put that in the calculator like the last one, and if I knew what the mean was, I just put it in, and yeah, I would get the 0.15. But now we're working backwards, so we could say probability of, if we convert it to z-scores, okay, a standard normal distribution, the z here has to be less than or equal to the z-score, but we calculate the z-score by using this formula up here, right? So we could say it's 58.2 minus whatever the mean is, which I don't know, divided by standard deviation is 5.9, okay, and that has to equal to 0.15. Okay, so now using your GDC, the inverse normal function. Okay, so have a go and do that. Okay, and we're going to do it for, actually I should do it in here, do it for 0, 1, okay, and what happens is you're going to get a value for this. Let me write it down. Let me have a look. It should be on the calculator approximately negative 1.0364. Okay, and then now it's just rearranging, like figuring out normal equation. We're trying to make mu the subject, so multiply both sides by 5.9, and then we get 58.2 minus mu is approximately negative 6.1. Let me write this bit in for you so you don't get confused. Times 5.9, right? Okay, and then what do? We minus 58.2 from both sides and divide by negative 1. I'm going to trust you guys to do that, and therefore the mean we get at the end is approximately 64.3. Okay, so we should just finalize and just say, you know, therefore mean weight is 64.3 grams, okay, for the scallops. Okay, let's go on to example 2. I'm just going to scroll down. It says find the mean and standard deviation of a normally distributed random variable x if p is if probability of x is less than or equal to 20 is equal to 0.1, and the probability of x greater than or equal to 29 equals 0.15. Okay, let's first do a sketch again. Okay, so it's asking us this time to find both, find the mean and find the standard deviation, so we don't know either. So there's actually two unknown variables here. So as soon as there's two unknown variables, you should also be thinking, probably need to use something like simultaneous equations where you've got to find two unknown variables. So we're going to come up with two equations. So it's like what we did earlier, but sort of twice, right? And then doing simultaneous equations. And we've got this important information here. So I don't know what the mean is. I don't know, oh, that's very messy. I don't know what the mean is. I don't know what the standard deviation is, but I know that at 0.1 or like 10%, okay, down here, okay, so that's 0.10, because remember underneath the whole distribution, it should always add up to 1, which is 100%, right? This value here, x1, is equal to 20. Sorry, that's not meant to be squiggly. Equals 20. Okay, along there. And then we've got x greater than or equal to 29. So this score here somewhere. About here. x2 is equal to 29. And this probability, or this area under the curve here, is 15%, or 0.15. Okay, so we need to work out, well, what's, if we convert it, you know, what's Z1, what's the equivalent, and what's the equivalent of Z2, what's the Z score that represents that position there. So we've got X normally distributed, mu sigma squared, we need to find mu and sigma. Okay, so let's go with probability of X less than or equal to x1. We know it's 0.1. I'm doing the left hand side one first. Therefore, let's change it to a standard normal distribution, converting it to a Z score. That's going to be 20 is your score minus mu over sigma is equal to 0.10. And then this is where you need to use your graphics calculator. And we should get 20 minus mu over sigma is equal to, if you do it in calculator, actually it's approximate because we've got to round it off, it's about negative 1.282. Okay, and then you just do normal algebra with this part, right? Normal algebra, and you rearrange, and we should get then, therefore, 20 minus mu is approximately negative 1.282 sigma, right? Now we're going to call that equation 1. There's two unknowns there. Let me draw a better sigma for you. Now we've got to do the other bit that we've got. Okay, so we've got probability of x greater than or equal to 29. Oh no, sorry, hang on. Less than or greater than? Let me have a look. So you've got probability of x greater than or equal to 29. But when we do the area under the curve, right, it goes like from the left to the right, because it doesn't know which side doesn't really know which side you're counting. It doesn't give you just that borderline. So we've got to go from, so that one, so we've got to find actually like this part, okay, of the 0.15. Does that make sense? So if that one is equal to 0.15, I'm just checking my work. Okay, that means probably x less than or equal to 29 is going to be 0. If I take away from 1, that'll be 0.85, sorry, or 85%. So we need to use that. So we need to go x less than or equal to that x2 value, or 29. Is 0.85. So now we can change it to a standard normal distribution. So z is less than or equal to that 29 minus the mean divided by the standard deviation. It's got to equal to 0.85. And then z2 then is equal to 29 minus mu over sigma, and is approximately equal to 1.036. Give me just a second, I have to go open the door for Nick. I'm just recording, that's all. Okay, so we get that value. Oh, here are the keys, Nick. If someone's going to the door for you, okay, good. Alright, sorry for the interruption. So we've got is approximately 1.036. Rearrange, so we get 29 minus mu equals 1.036 sigma. Okay, and that is our equation 2. Equation number 2. So now we need to solve it simultaneously. So solve 1 and 2 simultaneously. So I'll do the algebra for you guys. Just take care in your work, because it's a shame to lose marks on just the algebra stuff, which you've done so many times in like year 10 and 11. So make sure you are just careful with your work. So if we put it together, so you can use substitution or you can use elimination, either way. I might do here, I think I might do, let's do it by elimination. So I'm going to do equation 1 minus equation 2. So that's going to be 20 minus mu is approximately negative 1.282 sigma. I might just make this an equal sign so it's less confusing for you. And then I'm going to have underneath it 29 minus mu equals 1.036 sigma, and we're subtracting. So if I'm subtracting, right, when you work down the page, like kind of like in year 7 and 8 arithmetic, 20 take away 29, I'm going to have negative 9. Negative mu minus mu is 0. That's why I did that, because then the mu's will cancel. And then negative 1.282 minus 1.036. Let me see, what is that on the calculator? that'll be negative 318 sigma. Let me double check that with a graphics calculator. You guys know I can be terrible with my mental arithmetic. So negative 1.282 take away 1.036. Let me double check. Negative 2.318. Good. Okay. So I've got negative 2.318 sigma equals negative 9. And then I would just divide, right, both sides by negative 2.318. So then I can get sigma. And on the calculator, hopefully that will give me a value of approximately, we'll chuck back the approximately symbol now, is approximately 3.88 if you round it to 3 significant figures. Okay, now that we've got that value, we can sub it back into one of the others to get the mean. So sub back into, both of them are really similar. I might choose number 2, so then we don't have to mess with negatives. We still kind of have to anyway, but 29 minus mu then is equal to 1.036 times sigma, which is 3.88. What I would recommend is here, make sure you put in not just 3.88 in the calculator, put in the whole long big decimal. It'll make it more accurate. Whatever that value is, rearrange with the 29, make mu the subject. I'm going to skip that bit with the calculator. I'm going to let you guys do that, and hopefully we get a mean of approximately 25.0. Okay. Alright, so now it's your turn. Have a go at the questions. It is exercise 24D.2, which rounds off the end of our normal distribution chapter, which is great. And the exercise is on page 646. And please don't forget, there are also more questions in the Oxford textbook as well that you can use.